Myself, Dr. I. Pugadendi, Assistant Professor of Chemistry, Department of H&S and Annamacharya Institute of Technology and Sciences, Rajampeta. And we are having some discussion on a mechanism of polymer formation. That means what are the steps involved in the preparation of the polymer from the respective monomers. Those are the things supposed we have to discuss here. First initially we have taken free radical polymerization. It means that polymerization reaction which is involved by the presence of free radical is called as a free radical polymerization reaction. Here this polymerization reaction involves three steps. First step is a chain initiation. Here we are using some organic peroxides like a benzyl peroxides. We are using as a radical source. So these organic peroxides undergoes homolytic cleavage. Homolytic cleavage means that two electrons which is presented between these two oxygen as a covalent bond has been removed, cleaved equally, and one of the electron has been given to this oxygen and another electron has been given to this oxygen. This homolytic cleavage results in the formation of this intermediate radical. Further, this intermediate radical is highly unstable and readily it undergoes decomposition as a radical. It gives radical and CO2. So here we are getting a benzene radical. So this benzene radical undergoes delocalization. That means the electron, single electron which is present in this benzene ring can undergo delocalization throughout that benzene ring and make somewhat stable. So this benzene ring further initiates the polymerization reaction. Here we have taken that ethylene as a monomer. In this ethylene, that pi bond is there. The pi bond is made up of two electrons, which is shared sideways by the p orbitals of both of the carbons. That means the sideways overlap of pi electrons of these two carbon atoms makes available this bond for the polymerization reaction. So here this is very weak bond. That means the sideways overlap of that p electrons are very weak, and that homolytic cleavage has been taken place here, and one of the electron is given to this carbon and another electron has been given to this carbon. So now that radical starts to react with this ethylene. So that radical which is having that benzene radical which is having a single electron has been given to this carbon. Okay, already this carbon is also having one single electron. So mutual contribution of electrons between this R and this CH2 makes one covalent bond. That's why that R-CH2 bond has been formed here. So what is left behind? One of the single electron has been left on this carbon, and it results in the formation of the radical molecule. So this is the first step. So next one is a propagation step. In this propagation step, that radical molecule which is formed in the first step undergoes further reaction with another monomer, another molecule of ethylene monomer. Here also that ethylene is having pi electrons. Again it undergoes homolytic cleavage, and one of the electron has been given to this carbon and another electron has been given to this carbon. So one of the electrons from this radical gives its contribution to form a covalent bond. Another electron which is already presented in this carbon also undergoes to give that contribution to form a bond. So mutual sharing of electrons between this carbon and this carbon forms the CH2 bond, which results in the formation of huge molecular radical. In similar fashion, these also reacts with the n number of ethylene molecule which gives a huge molecular radical. So this huge molecular radical further undergoes termination. So termination has been taken place in two different ways. One is a combination, another one is a disproportionation. In this combination, that huge molecular radical undergoes combination with itself, and it gives that linear chain. That means that huge molecular radical combines with itself, and it completes that polymerization reaction. Thereby, it gives a linear polymer chain. This is the one kind of termination. Another one is the disproportionation. In this, one of the hydrogen at adjacent carbon has been removed, and it results in the formation of pi bond between the terminal carbon-carbon atoms. So thereby this termination has been completed. So next one we have to discuss about the mechanism of cationic polymerization. Here that polymerization reaction has been initiated by the protons present in the acids. Maximum we are using sulfuric acid or hydrofluoric acid or boron trifluoride as initiators. This reaction proceeds through the formation of the carbocation. carbocation. Here the protonation of this pi bond occurs, and which results in the formation of the carbocation. Here that positive charge has been stabilized by resonance of this benzene ring. That means this positive charge has been delocalized throughout the benzene ring, thereby it becomes more stable for the reaction. So next step is chain propagation. So the carbocation which is formed in the above step undergoes further reaction with the another molecule of styrene. Here we are using that monomer is styrene molecule, and it generates another carbocation. This carbocation further reacts with the n molecules of styrene, which gives a huge carbocation molecule. So this huge carbocation molecule has been undergoes termination. So the termination can take place by two different ways. One is reaction of bases or reaction of anions, makes that positive charge to neutralize, and thereby the termination has been completed. So next step is removal of hydrogen atom from the adjacent carbon, neutralizes the positive charge, thereby it forms double bond here. In this way the termination has been completed for the cationic polymerization reaction. So next one is anionic polymerization reaction. In this anionic polymerization reaction we are using bases, maximum sodamide and potassium amide, lithium amide has been used as a anionic source here. This negative charge on this anion shifts this bond to this carbon and makes the carbanion. So here this is called as a carbanion. That means any molecule which holds negative charge is called as a carbanion. So here also that negative charge has been stabilized by delocalization process. That means this negative charge delocalized throughout this benzene ring and makes available this anion for further reaction. Next step is chain propagation. In this chain propagation, that carbanion which is formed in the above step undergoes chain reaction with n number of styrene molecules. Thereby it forms a huge carbanion, huge molecular weight carbanion. That means carbanion which is having more molecular weight has been formed in this chain propagation step. So final step is the termination. Here that huge molecular weight that carbanion undergoes termination. Simply any solvent molecules, here water molecule, any solvent molecule can terminate this polymerization reaction. So it donates H plus ions, thereby this negative charge has been neutralized by this H plus ion, and the polymerization reaction has been completed. So this is the mechanisms involved in these different types of polymerization process.